Hello and welcome. As we've been exploring inequalities, we keep peeling back more layers and trying to make connections. With single variable quadratics, for example, we found roots and tested intervals. If we had two roots, there were three intervals to check. If we show the graph formed by this inequality by including y, we see that the points above the x-axis are consistent with the solution shown on the x-axis, which is also reinforced if we shade in the solution. In this episode, we'll explore how we can graph multiple quadratic inequalities and other inequality statements. We discovered with systems of linear inequalities that graphing is the only way to realistically find our solutions. We made sure we were able to graph the inequalities efficiently, and then identified the desired solution as likely an intersection that only included values from both, or possibly a union that could be values from either. This notion extends to quadratic and other more complex inequalities too. Here are two quadratic inequalities we'd like to evaluate together. As the first inequality factors easily, we'll build our graph from there. The roots are -3 and 1 when y is 0. A line of symmetry can be placed at the midpoint between the roots to help us identify the vertex point. And we know when x is 0, the y-intercept is -3. This is enough to draw our graph. Our inequality is just greater than, so we use the dashed line and shade above. With the second inequality, we recognize it has a vertex of 0, 0, shown in graphing form just to reinforce the concept. And a being -3, we know if we move 1 from the vertex on the x-axis in either direction, we must go down 3, giving us the points -1, -3, and 1 and -3, and this parabola. Once again, we check the inequality sign. It's only less than, so a dashed line is used, and we shade below. We'll check one point in the intersection just to be sure. Let's try 0 and -1. This point satisfies both restrictions, as we'd expected. Of course, any types of inequalities with the same variables can be solved by putting them on the same graphing plane. Let's start with this quadratic. Start by putting it into general form so we can use the direction of the sign to indicate where to shade. Add 4x to both sides and just reverse the direction of the entire statement. Let's use a data table this time to find values for the boundary line. We need a solid line and graph below as directed by the inequality sign. We'll add the linear inequality y is greater than x minus 2. This can be drawn quickly using the intercepts 2, 0 and 0, 2. Greater than lets us know to use a dashed line and shade above. And we get our intersection of common values. As always, good to test a value like 0, 0 just to confirm. Graphing is proving to be an important and efficient method of finding solutions for various inequalities and their combinations. By drawing on your skills to generate the graphs formed by various inequalities and putting them in the format that starts with y, our graphs can be used to accurately find solutions. We can even combine higher degree inequalities, and as we learned earlier, multiple inequalities. We will consider another strategy to solve inequalities using sign analysis in our next episode.